Hello everyone, hope you all are doing great. So today I will be discussing a question which was asked in LeetCode Biweekly Contest 162, and it was the question number 2, minimum removals to balance array. So in this question we have been given an integer array nums and an integer array and an integer k. So here they are saying that an array is considered balanced if the maximum value in it and the minimum value in it are not exceeding by a factor of k. In other words, it says that the maximum element must be at most k times the minimum element. Okay, so that's the case for a balanced array. Also they are saying that we can remove any number of elements from this integer array nums without making it empty. So it must not be empty, and they are saying we can remove any number of elements from it. So what we have to find is we have to find the minimum number of elements that we have to remove, which will ensure that the remaining array is balanced, right? So what we have to do, let's say we have an array which is called nums. Now it is, let's say it is unbalanced. So what we have to do, we have to remove certain number of elements from it to make it balanced. In other words, now what balanced means as per this question, it means that the maximum element of that array should not exceed k times minimum element. Okay, now what we have to do is we have to find the minimum number of such elements that we can remove out of the entire array, right? So let's take an example here. We have example 1, 2 comma 1 comma 5, and the k is 2. Now k is equal to 2 means that the maximum value of that array must not exceed 2 times the minimum element. Okay, so the output is clearly 1 because we can remove 5 and then we can have this array 2 comma 1. Here the maximum value is 2 and the minimum is 1. So we have a factor of 2. So 2 is at most 2 times 1. So 1 is correct. Similarly here we have 2 because we can remove 1 and 9, right? So here we have this array 6 comma 2 with a factor of 3, right? So yeah, that's the question. Now how can we solve it? Okay, so one observation that comes to my mind is that here the order of these elements does not matter. Okay, like nowhere they have mentioned that any sort of order is required between the elements, or anything related to order is required. So it's not needed. So it's allowed to sort the array. Okay, also now that we can sort the array, the minimum element of that array will be at the extreme left if I am sorting it in non-decreasing order, and the maximum will be in the right. Okay, now what I can do is I can just check for any sub array if the left element and the right element are having a factor of at most k or not. Okay, so a naive approach here can be, let's just draw some diagrams now. Okay, let's draw some diagrams. Let's say we have these elements. Okay, hold on. Okay, let's say we have 6 elements in the array, and what we have to do, we have to find the minimum number of operations. Okay, so what can I do? I can maybe what I can do is I can first sort this array, right? So now the elements are in non-decreasing order in some sort. Okay, so what does this imply? The leftmost element for any sub array in this array, after assorting it, the leftmost element of this array will always be the smallest out of any sub array, and the rightmost will be always the maximum one. Okay, so what I will do is I can just iterate through all the possible sub arrays and then check if that array is balanced or not. If that array is balanced, I can remove all the other elements, and then that can be one of the candidates for my answer. Okay, let's understand this through an example. Okay, let's say I have chosen this sub array, right, from here to here. Okay, like from here to here. We have chosen this subarray. Now this is the smallest value here and this is the biggest, because this entire array is sorted. Okay, so if these two elements are following this condition, like the factor of k, if they are following that, what I can do is I can remove all the other elements and then make our array balanced, right? So in this case we are needing two operations, because I am removing this and I am removing this, right? So we are having two operations. Whereas if I am choosing this subarray, if I am choosing this subarray, this, okay, then we have these three elements that need to be removed. Okay, and we also have to check if this subarray is like smallest or not, right? Okay, great. Now what can be done is, what I can do is, right, so we can iterate through all of these subarrays and then just pick one of the answers, right? That will clearly take me big of n square time complexity, because we are iterating through all these subarrays and the total subarrays are of the order of n square. Total subarrays is equal to n into n minus 1 by 2, something like that, right? We have these number of subarrays total in any array, right? So it is clearly n square, so it's not feasible, because the constraints won't allow us a quadratic time complexity. So what can be done? Maybe for each element, okay, maybe for each element here, okay, like for this I can find the furthest element which will satisfy my condition. Okay, let's say this element is satisfying my condition. For example, we have k is equal to 6, right, and we have n is equal to, and we have this element is equal to 2, and this element here is, let's say, 10, right? This element is at most 6 into 2, 12, right? It is less than or equal to 12, and let's say this element is 14, so it is not satisfying, because this is bigger than 12, right? So we have this subarray, right? Any element which is at the left of 10 will also satisfy my condition, but I will not consider it, because then if I am considering this subarray, right, then I might as well take this element also, because it is also satisfying. So I can have a smaller number as the number of operations. So I will always choose the furthest right element which I can choose to make the subarray balanced. Okay, so for each index I will choose the furthest rightmost index and then remove all the other elements out of it. Okay. Okay, for example, if I chose this subarray, okay, if I am at this index and I found this index to be satisfying my condition, right, this, so I can remove this and this, so my answer will be 3 for this subarray. Similarly, I can do this for all of the subarrays, for all of the indices, and then just pick the minimum value for the number of operations. Now for each index we can simply use binary search, because we are having a monotonic array. Okay, so we can use binary search here. Like if we are having this element, okay, so in this range I can perform binary search for an element which is at most k into this first element. We can use the binary search. Okay, then we can maybe move with the implementation for this, and I am sure that implementation after it the approach will be way more simple for you. Okay, we have this. Now I will just sort. Great. Now I will iterate through all the indices, the exact thing that we are doing. Okay, so okay, now for each index we have to find the rightmost index. Okay, so for that we can either use binary search or we can use a user defined STL function. Sorry, we can use a library function given by C++ STL, which is upper bound. Okay, so we can use it. Okay, also Okay, so we are founding this nums of I into k, right? Also we have to subtract current, also we have to subtract nums dot begin to get the index. Great. Also as this is upper bound, so we will just do index minus minus. Okay, great. Now this will be my range, so integer range will be, if what will be the size of this range from this index to this index. Let's say this is index number 2 and this is 4, so my range will be 4 minus 2 plus 1. That's what we will do. So it will be index minus I plus 1. Okay, now what will be the elements out of this range? They will be integer removables, they will be n minus range. Okay, because if I am choosing this range, all of these elements will be n minus this range, so it will be n minus range, right? And I will also be picking the smallest value here, so I'll just do this, and in the end return the answer. Okay, also as you can see, we have nums of 5 of the order of 10 raised to the power 9 and this k of the order of 10 raised to the power 5. So we can also have issues with the integer overflow, so we can maybe use long. So for it I will just use ll. Yeah, so yeah, let's run this and see what happens. Yep, all the test cases got accepted. Now let's submit this code. We are getting a signed integer array. Oh, okay, because this nums of I is an integer and this k is also an integer, so this product is giving us and overflow. So I'll just cast it into a long and also cast this as a long. I'll just use this test case and let's run to see what happens now. Yes, it works. Let's submit the code. Yep, it got accepted. Now the time complexity for this will be big of n log n, because for each index we are doing the binary search on the right part of that array, right, on the right part of that index. So it is n log n, of the order of n log n. Now I think, right, I am not sure yet, but I think we can further optimize this using 2 pointers method. So let's see what I am thinking right now. Okay, I might be wrong, but let's see what happens. Okay, let's say we have this subarray. Okay, great. Now if I am, let's suppose I am standing at this index. Okay, now for this index we have found the rightmost index to be here. Okay, very well and good. Now we have this range, we have this range, so the number of operations will be 1 2 3 4 5. Great, we have found this. If I am moving this index to the right, in other words, if I am going to the next I here, if I am doing that, then my next rightmost tip of this range will be only and only moving towards right. That's what my intuition says, right? It will be only moving right, because here we are having an element which is at most bigger, right, which is bigger than the previous element always, because this is a sorted array. So this element is bigger than this, so we can also accommodate maybe bigger elements here, right? So we can push this pointer towards right. So for each element we can just keep pushing both these values to the right, and then it will give us the answer in the time complexity big of n. So we can use the 2 pointers method here, right? So let's try to implement that. I'll just do this, and let's make the rightmost pointer will be j is equal to 0. Cool. While j is less than n, and nums of j is less than equal to nums of I into k, then this range from I to j will be valid, right? So answer will be j minus I plus 1, this range, and I will just do j plus plus in the end. Cool. This is what I will do. Okay, let's run this now and see if it works. Okay, it's giving me wrong answer for all of the values. Okay, although why am I doing max? It should be min. Yep, it should ideally work. Okay, it's not working. Maybe I'm being weird. Okay. What's getting wrong here? Okay, we have sorted the array. Good. Oh, we have to do this n minus this range. Okay, fine. It should be n minus this range, obviously. Yeah, it got accepted for all the cases. Now let's submit this code and see what happens. Again we made the same mistake. Wow. Yep, let's submit it again. Cool, we got this solution accepted. Now what is the time complexity for this approach? Okay, you are, of course, you are seeing here like we have a while loop inside a for loop, so you must be thinking we are using big of n square time complexity, but it's not true. Why? Because we are using the two pointers method. Okay, let's understand the time complexity. We have this array. Okay, and let's say we have one pointer here and the other pointer here, right? We have the pointer at the beginning initially, right? Now what I am doing, as I am standing here, it will first find the pointer for this, right? It will find the pointer for this first. The pointer will be coming here, then coming here. Okay, here it found the maximum range. Okay, correct, right. But then it will move one to the right, and the range will be this part, right? Because we are doing j plus plus once, and then we are checking the answer for this range, and then we are doing j plus plus. So we are having this range. Now I am moving this arrow right again. I am not doing like I am for each position of this array, of this arrow I am searching in the entire array. That's not what I am doing, right? So this will take a time complexity of big of 2 times n. So that's like just the linear time complexity, and yeah, that's the solution. And I hope you like it. Also feel free to comment down anything that you have in your mind, or any thought or any doubt, and I am happy to interact with it. And thank you so much for watching this video, and see you with the next one. Bye.